Virendra mentioned, in this session, we will have Scott, Michael, and Andres presenting. All have been advised by Professor Sion. And we'll go ahead and get started with Scott. Scott, are you ready to start your presentation?
Yeah, sure.
Okay.
Okay, let me share my screen 1 second. All right, can you see my slides?
Yep.
All right. So good afternoon, everyone. My name is Scott. I'm really excited to be here today, and it's nice to see a lot of people here on Thursday. And so I'll be presenting my capstone project, which is build a to-do list app in command line interface with Python. So this is today's agenda. I'll begin with the problem statement and why we need to build this app in the command line interface, and what are the benefits of it compared to the traditional graphical interface. And then I'll show some other people's approach and how my approach is different. And I'm going to collect some data and explain why it is faster than the graphical interface. And then I'll show the demo, and then some finding, conclusion, and a couple future work that can be done for improvement. And then I'll leave some time for answer questions. So in our daily life, we might forget to do things that are important. We might want to get things done, or some of us are struggling to keep the deadline and get overwhelming with the amount of work you've got. So as a software engineer, these happen like more often when switching between projects or getting blocked to implementing new features or fixing bugs. A lot of reasons can cause falling behind the schedule. So we need to have something to track our task, and it should be a small and lightweight, works across different operating system or platform, and also allow user to customize their own favorite features. So the to-do app in command line interface, it's a perfect choice to solve this problem. It improves the memory by acting as an external memory to keep track everything. It will also increase users' productivity by prioritize the tasks which are more important. And lastly, it also motivates users to clarify their goals so they can break down their long-term goal into small short-term goal and then gain more confidence as they check off each of them from their list. So why we choose to implement our to-do app in command line interface over the graphical user interface? So GUI allow user to interact with electronic device with the help of graphical icons and visual indicators, while the command line interface only takes commands for interaction. So since the GUI is based on graphical, it is very easy to understand for beginners. And while the same time that the CLI is more difficult because users have to memorize the command. Also, GUI requires more memory because there's a lot of graphical components. And then GUI use mouse to execute command, while CLI is using keyboard to do that. So CLI is generally more faster. And GUI can change the appearance with customizable options, and it's more flexible. And you can see a lot of apps that can allow you to choose different things, change the color, or I'll give you a little bit of choice of what the UI you want it look like. And then GUI is using both keyboard and mouse, and CLI is only using keyboard. So CLI has higher precision compared to the GUI. And then let's dive deep into the key difference between CLI and GUI. So GUI doesn't require, like I mentioned in the previous slides, GUI doesn't require users to memorize the command. So it is less challenging for beginner. And then GUI is easier to do multitasking because we can have multiple windows opens. We can have different things running at the same time. Even though CLI is faster to perform tasks, but CLI we can writing a script that can allow us to automate a series of instructions to perform the task automatically. So graphical, the GUI usually connect with allow we to connect another computer remotely. While on the other hand, connecting with CLI is a little bit difficult. Professionals are maybe required to get access to another electronic device. In the CLI, the interface is consistent for all the time, but in the GUI, the interface change with the update of the software. So we might have a big major update that we have to re-familiar again all the features and all the buttons, where they're located, where they at. And at the end, the CLI offers more control over the system through the command line interface. And there are some limitation in GUI where the user can accessing the folders or perform certain tasks. So overall, the reason why we choose CLI over GUI is you can write a code or giving instruction to the computer interface, which gives you the better overall control to the users. And then try to navigate through different graphical icons that can make GUI runs really slow. So CLI is performing really fast because of that. This case is particularly true in many IT professionals. And sometimes professionals are required to work in more than 2 languages. So CLI is a great option for professionals who need to work on multiple programming language. All right, next slide. So here is an example how other developers building their CLI app. So this one is a really simple implementation of a k-neighbors algorithm. It is pretty straightforward. You just train the model and predict the result. And as you can see here, we can use the Python 5 package, which can automatically generating CLI from any Python project. You can just simply import a package and then call the package at the end of these files. And here is the another examples. In these examples, the programmer is using the ARG parse, which is the recommend command line parsing module in the Python standard library. It allows you to define what argument it is required, and then the ARG parse will figure out how to parse those arguments through the C-star ARGV. The ARG parse module will automatically generate help and usage message, and then check if there's issues, errors, if user passing some invalid arguments. So these are some common package for creating a Python CLI. Beside the ARG parse I was just talking about, we also use the click module, which is highly configurable to create beautiful CLI with less code. And then the docop is also another lightweight package that can automatically generate a parser for it. So for my approach, this is the main 3 package I'm using. The typer would be the main package, handle all the command line arguments. And then rich is the package, can turn this app to display advanced content such as table markdown, syntax highlight code. And then SQLite is a C language library that is implementing a really small, fast SQL database engine. And this one is actually the most used database engine in the world right now. And it has been widely applied to a lot of mobile phone and most computers and cons bundle inside. There's a lot of application people use every day. And now this is my app. It's gonna be look like. I'm gonna reshare my screen so I can show the demo right now. Just give me 1 second. So this is what my app looks like. There's mainly 3 files here. I have a database files, which is used for the SQLite database. And it's pretty standard SQL language. You can see the database is called to-dos. And then we are checking, we are passing the query here, checking if the table is not there, we're gonna create one. And then these are pretty standard, get all creating, delete, or make any change query. And then we have our models for the program. And this is a really intuitive one. It basically just consists of constructors and then all the attributes our program is requires. And then lastly, this is the typer module. So this is the main one that's handle all the parser, handle all the arguments. And then as you can see here, we have all the command here, adding, delete, update, complete, and then show the tables. And then this is the table looks like. We got all these columns here, and then it's gonna return a table, and then check the database. And when we get the query from the database, then we're gonna parsing and then convert it to our programming. So let me show you a quick examples how to use these app. So you're gonna type Python and then run these main files. And when you're doing all the command line app, you're gonna pass the help to see what these app does. Let me scroll that up a little bit. So we can ignore the option section. We can focus on the commands here. So this is basically all the commands this program support. It allows user to add a new work items. You can mark the items complete. You can delete it. You can check the entire table, see what's inside, and then you can modify your work items. And then this is the table is going to look like. I already have some work items there, and I'm going to show you how to add one. So we always gonna start with the Python and then these file names, and then we're gonna type the command we try to do. So we're doing adding here. So right now let's just say we're gonna add another items. So study Javas, and then we're gonna set the priority is high, and then we're gonna put the category there. And I just need to hit enters, and it will update the tables there. When we need to modify these items, we can just do a update command, and then we want to change to study C. We want to change our priority to something medium, and it's still going to be a study. This one I'm missing the positional. So basically, you got to put the items you're trying to modify. So the one we just created is the 5th item. It has ID 5 being automatic assigning. So we have to add 5 right here. So this will update the item we just run the command against. And once we're done with it, we can just mark it complete. And then also by passing the item ID. So this will mark the item complete. The status will get check off. And it also will add a date, the current time as the data complete. And then once we're done, we try to get rid of it. We're just gonna hit the delete these items. So this will remove the items.
Scott.
Yep.
Just so you know, you have about a minute left.
Okay. Yeah. Let me switch to my slides again. All right. Okay, so we just covered the how I was approaching this program, but now we're gonna do some data collections and we're gonna analyze the data. So in order to find the bottlenecks in our program, we can use there's a tool called Logria, which is a powerful CLI tool. We can collecting logs to analyze how fast our program is run. Here is the examples, what the logs look like, and then what command we need to run. After I run this program, we're getting the result here. So these are all the lines where we want to pay attention because they're representing the main function our program is executing. You can see the numbers. They're really small because they run really fast. And then all these lines include the three source code files. We have database, the modules, and then the main parsing files. So this is gonna lead us to our finding. So basically, our program is really minimal design compared to other similar task management system like To Do, TXT, Task Warrior, or Ultra List. And it's really quick to set up because I say there's only 3 packages there. And then the command I just showed in the demos, you just start with the Python file names and then the commands you try to run. And then if you forgot the argument you pass, you can just check the help menu. And then the source code is not that long. Overall, it's only 200 lines, so it's really user friendly. Even though you're just starting programming, you will be really easy to understand the code. So let's talk about our conclusions. So basically, we were trying to looking for a lightweight cross-platform app that can track our daily tasks. So I think this app does exactly what we're looking for. And then it is actually follow the model view controller architecture we've been learning. So a lot of beginner can easily modify and add their own features to the program. It is really highly customizable, and then the styling has been updated. You know, it supports all different all different kind of styling, highlighted syntax, emoji, a lot of stuff, and we can easily swap the storage solution because we actually have a separate database files. And then we, from our data collection and data analysis, we're getting the CLI. Our CLI app is run really fast with less complexity compared to the GUI. Some future work is we can adding more columns there to track more information for each items. And then the data storage, we can easily swap with other database or cloud solutions. And then since once we adding more features, once we adding more columns there, we might have to redesign our table to avoid it being look huge or have so many columns there. And then maybe we can add a optional graphical interface for someone who still prefer to use that, you know, or have as a options. And here is all the reference. And then that's it if you have any questions.
Very great application and presentation. One question I have is, what was the biggest challenge while conducting your project? What was the biggest challenge that you faced?
The biggest challenging is it feels like a time strain, like because most of the time we're actually writing paper, so I don't feel like there was enough time to development the actual project. So that's kind of the challenging. I was trying to make adding way more features than what I was originally designed, but it's kind of running out of time. I have to spend more time on the paper.
I see. Okay. Does anybody else have any other questions?
Yeah, I was just wondering why you decided to do this project.
So basically, I work as a software engineer on the daytime, and then I developing the code in Linux system, and then but I was running remotely from Windows. So I was looking for a solution like this to keep tracking of what needs to be done to have, a live way to do app that I can access anywhere. And then I'm doing a lot of stuff like in the command, so it's definitely better for me just have to implement it in a CLI.
Interesting.
Okay, if no other questions, thank you, Scott, for your presentation. You did a great job. With that, I think we'll go ahead and go on to the second presenter. So Michael, are you ready to go next?
Yeah, I had a YouTube video pre-recorded, so I will share that right now. One sec.
Sure. Michael, is there supposed to be sound right now?
Yeah, can you? Oh, sorry. Can you not hear that? What?
No.
Findings and conclusion. Is that better?
Yeah.
Okay, here, I'll go back. Sorry about that. My name is Michael Butler, and this is my capstone presentation for my master's in computer science. My project is blockchain's impact on the accounting industry. So first we'll start with the agenda. And first on the agenda is the problem statement, followed by the topic, objectives, expected results and background, and I'll show my demonstration, data analysis, and then lastly, findings and conclusion. So first, the problem statement. My undergraduate degree is in accounting, and one of the issues that was talked about a lot is how blockchain could change the industry, because auditing financial statements could become less needed as blockchain is more widely accepted. Blockchain is a distributed and immutable ledger. This allows for real-time verification of financial transactions. So the old way accounting firms do a lot of their business, which is look back and verify the financial statement and transaction. So my problem statement are will blockchain be adopted by major accounting firms? And also, how quickly can we expect these changes to occur? Topic and objectives. My goal of my research paper was to explore the future of blockchain and auditing, and also the impact that it could have on the financial institution. Also, an important thing about this was looking at how possible tech evolutions, how quickly they could occur, and when they might be widely accepted by accounting firms. My expected results. My expected results was that there would be a slow adoption of this new technology in the accounting. One of the reasons I believe this is because the accounting industry tends to be a pretty conservative and rigid industry that has long-standing standards. Eventually, I think that adoption of blockchain could be widely accepted as more investment and more investment from some of these big four accounting firms occurs. Some background. Blockchain uses its is a peer-to-peer technology, like I said earlier, and is distributed in immutable ledger. One of the institutions that's been pushing for this the most in the financial world is Deloitte, which is a big four accounting firm. They've published a lot of large peer-to-peer studies, and they're bracing for it in the future as their business and auditing changes. One of the most One of the technologies that's most applicable to accounting are smart contracts, which are digital contracts stored on the blockchain, which are automatically executed when there's predetermined terms and conditions are met. And this is what I decided to do my demo on, and I will show that to the demonstration video of that now. Now we're going to look at a smart contract which can provide real-time verification on the blockchain. So this is used using the Remix IDE on Ethereum. So this is written in the Solidity language, which is shown here at the top. The contract is then written out here with the variables and the constructor and the inputs. In order to compile it, we go to the compiler. After doing that, the smart contract is now compiled. To deploy it onto the blockchain, we have to go into the deploy and run transactions. In here, we can set the value of the contract, and then the address of the freelancer and the deadline. We put in the example address right in here and the deadline. After we press deploy, it should change the transactions recorded from 5 to 6. This is how we know we created the smart contract. This will add it onto the blockchain. The transaction will be there forever. As we can see, the transactions recorded changed from 5 to 6. This means our smart contract was deployed. If we go down into deploy contracts, we can see the contracts that we have created. This can verify transactions in real time because it is an immutable and distributed ledger. So that was a quick demonstration of a smart contract, and that was a very simple one, but one of the things that is helpful for accounting firms is that it's immutable, so you can't go back in time and switch some of the transactions that occurred, and there's the ledger that shows all of the contracts on the blockchain. Okay, next I will talk about approach to my research. And the approach for research were to find the investment dollars and the patents from the big 4 accounting firms and collect those. I put this in a table and graphical forms. It showed the examples of the spending that these accounting firms have done. One of the interesting things that I found is the overall amount of investment dollars that's spent on blockchain is rising, as you can see here, from $75 million in 2015 all the way up to $400 million back in 2019. One of the interesting things that I found with Ernst & Young is you can see here in the industrial areas from the amount of patents overall that have been filed. Ernst & Young actually has the most patents out of all the accounting firms filed, and you can see here, in comparison to other industrial areas, they're kind of in the middle of the pack is in terms of how many patents have been filed. It was hard to find the overall investment dollars other than Ernst & Young in the blockchain, but as you can see on the far right column here, EY, Ernst & Young, has 6 patents overall, and one of the interesting things that I found was that Deloitte actually has no patents for blockchain technology, which is interesting because they, as I said earlier in the research paper, they have been really promoting that they're on the cutting edge as far as this technology, and have published multiple research papers about it, but they're lacking, I guess, their competition when it comes to patented blockchain technology. Sorry.
Sorry about that.
There is more investment money being spent by China in comparison to other countries, at 46%, and United States at 24%. So there's a big lead as far as China's growth over the United States in blockchain technology, which will be interesting to see as the years go on. The United States can catch up. And then overall, there has been a lot of patent.
So that was the end of the presentation. Sorry. Do you guys have any questions?
I have one question. Of the technologies that you used in your capstone, did you learn or work with all of them in your program, or was any of it using knowledge like from your undergrad or just other research?
Yeah, I used both. A lot of it was more from like I took my past accounting knowledge from my undergraduate, and then I used some of my programming knowledge that I learned throughout my master's degree.
Okay, thanks.
Great presentation. I have a question on the US patents that you were mentioning. Can you kind of explain a little bit more about what kind of patents that you're talking about?
Yeah, it's just I found information on the blockchain related patents that were filed, and then there was kind of a by industry study that I showed, and it showed in the industrial industry with EY, which is a Big Four accounting firm, that they were kind of leading the way as far as accounting firms, as far as patents filed goes.
Thank you. Any other questions?
If no other questions, then thanks again, Michael. Great job. We can move on to our final presenter for the session. So Andres, are you ready to go ahead?
Yes, can you hear me all right?
Yes.
All right, just give me 1 sec. Okay, can you see my screen?
Yes.
Okay. Hello, everyone. My name is Andres, and for my capstone project, I decided to go along with blockchain. It's mostly focused on a way to approach it towards more public people, or in a more specific way to make it more accessible for others. For our agenda, we have a very brief introduction, the problem statement, my main motivation, some background, related work, the approach, data collection, analysis, some findings, a little visual demo, my conclusions, future work, and references, as well as a brief Q&A. So for the introduction, we have this very nice quote from Nathan, which basically says that blockchain technology can be used to record virtually anything, and it's quite true because in many aspects, it's not only used in transactions, since that's what most people associate it with, but its potential can even reach various scales. So here we're going to discuss brief origins, the accessibility obstacles presented, which is my main focus here, although it has more obstacles, and a proposed solution that can serve for illustration, perhaps for future researchers. So in our problem statement, we have that the public blockchain, here it is important to remember that I'm discussing public. There's also private blockchain and this permission type blockchain, which we can get to later, but here we're talking about public. And it has various advantages. One of the most obvious ones is that it provides a great deal of security, since the blocks are kind of mutable to change between each other, since when a change occurs to one, all the others one detected. So it's pretty difficult to alter it. However, this is mostly associated also with inefficiency. That's why such operations are usually quite costly to run. Mainly, the technology works on proof-to-proof mechanism to validate transactions, since this is going to be our main example of transactions. And it has to ensure trust to add them to a network. For so, this mechanism requires a lot of computational power to solve complex mathematical puzzles to process. Like I said, it's pretty secure, but most of the time, it's not always cheap in terms of time and our resource. My main motivation is because I really like the technology. I want to get a little more involved in it. I just started digging deep into it when I started this project, and like the enormous advantage it has when conducting this sort of transaction is also to not only remove intermediaries from the way, but provide trust between the one who does the transaction and the one who receives it. For a brief background, well, this technology was first introduced as a tool for achieving integrity in distributed software systems. We'll know that there's distributed and there's also a bit more centralized ones. Various tech fields show concern for resolution to different issues, but like I previously said, I'm mostly focused on accessibility. There were tons of related work, but in this case, the main approach that we're handling here has to do, like I said, with reducing costs. So there will be many technologies to talk about, but this one has great future potential precisely because what I said earlier of removing intermediaries and providing trust. So the extent of the solution has to incorporate a solid blueprint as to what should follow. Mainly, I got inspiration thanks to many professional research notes that I consulted, which you can later find reference. So obviously, like I said, it has advantages, but like the main thing here to resolve and pretty obvious hindrance is the branch of accessibility. So as for the current system, it needs to move easier again, little agility, and this can be achieved by reducing the number of processes, which is the main way I decided to go about this, because it seems pretty flexible depending on the networks. And so this design must consist of finding a way to properly divide the task in a manner that unnecessary processes can be removed and then costs can be reduced. Data collection was mostly from certified libraries such as the CDU library, also the IEE library, and ACM library. Ultimately, these results were proper guidance in my case so that I could clearly see what would most likely work and what most likely wouldn't, because many people have already done research on this topic, but the approach they took varied greatly. So thanks to this, now I can see what paths are most likely likely to be successful and ones that are not, because we're considering a primary approach. It was mostly thanks to quantitative and categorical data to do this kind of research. As of now, we have that, taking an example, Bitcoin, but you can use our cryptocurrency as well. I use this one because it's the largest one. The average confirmation time is our current level of 10 and 88 minutes, down from 18.45 was yesterday and 132 1 year ago. So there we have a nice little fact. And regarding the transaction fee, it's currently at 1.5 USD from yesterday, which was 1.8. A year ago was about 11. So we can see that there has been concern to resolve this issue. It hasn't been entirely isolated or like no one cares about resolving it. So the main essence of blockchain, as probably some people know, are that the nodes have to be linked, and each one requires, in a certain way, another one to proceed. A way to increment efficiency is to kind of force this trust in them rather than simply let them be alien to each other. These systems make heavy use of cryptographic techniques to ensure integrity. This is extremely secure, but on the other hand, it is vital that for public settings, there has to be more pre-established trust so that processes don't take so long when we're talking about a lot of people, because congestion on the network also occurs quite frequently. So the concern regarding public blockchain efficiency has been considered, as we could look at some of the reports. However, despite improvements, there still exists some room. I created a little video to explain this a little better. You can later find it here, but I also have it here, so it's quite short. Let me know if you can hear it, please. Here we have a common visual representation of a blockchain network. Please notice that our blocks are linked together in a sort of chain. The blocks whose chain is still blank can be visualized as a new block, one requesting entry into the chain. When a new block requests submission into the chain, our participant blocks have to validate this process. Once this is completed, and if indeed it was validated, the new block can be added to the chain. Here we have a fairly similar scenario, although here we have greater number of blocks. However, it still serves the same purpose. Assuming we still have a new block requesting admission, what if we could reduce the number of validations to rather specific ones? This could range from 1 to n being our block number. Of course, if we only require specific blocks to validate rather than all, the proper way would be that these key blocks remain hidden, only revealed when they are needed. Also, key designation would have to change per request. That means for each request. So their identity is much less likely to be compromised. Once the process is completed, the designated blocks would approve for all remaining blocks, therefore achieving the same result. Admission for the new block is now granted. Here we have a common visual. In conclusion, we have that the blockchain is indeed transversal and a great moment nowadays. But like I said earlier, it's suggested that there is still vast room for improvement. When we're talking about public blockchain, this is a pretty obvious issue. So my main focus was, as you could see on the visualization, that if there's a way to increase this kind of trust on the blocks so that instead of having to trust each other, they only have to trust specific ones, like the resources can quite be upgraded and ultimately achieve results in a faster motion. Also, this would prevent congestion, which also occurs not as frequent as before, but still occurs. As future work, well, it has to be considered that this technology is expected to have great results. Of course, as we all know, as time goes by, humanity ultimately finds new technologies. So this one could be replaced eventually, but the main thing here is that we exploit disadvantages in a way that it can become worldwide. So the future work will mainly reside on the implementation research and either construction of this specific model or modification to specific networks so that they can follow the same path, and if need be, it can be modified to a degree where it can be implemented. But several tests will have to take place to ensure this success. Unfortunately, due to the time of this course, I didn't possess the resources to achieve this, but it is very interesting, so I believe someone can take part of it, or even me, if I have enough time. Here are my key references, and thank you. If there's any questions, go ahead.
I have one question. If
Sure.
you had to repeat this capstone process again, is there anything you would do differently, or do you have any advice in that regard?
I don't think so. I mean, at the start of the project, like I said, I wasn't like an exact expert on this subject, but it really catch my interest, and so I had to document myself a little bit. If I were to start it again, I would probably find like a better way or a manner to optimize this better, but so as to change something, I don't think so.
Okay, thanks.
I have a quick question. Great work. Is your capstone project connected to what you want to do after you graduate, like further studies or within your career?
That's a great question. I think it's a bit early to say. I would really like it, but of course the future is uncertain, so I can't really say about how much time after I graduate. But at a point, yeah, I would really like it.
Okay, thank you. Any further questions? I think no other questions. Amanda, can I just address one thing before we end?
Sure, go ahead.
Okay, thank you. First, thank you, Amanda, for leading the session. Awesome job. And for all the presenters today, I like to congratulate and thank you for all your hard work. I know it's a big challenge to do your capstone project, do all the implementation while writing the paper and writing the preparing for your presentation. So very good job throughout the course, and I hope that you can utilize what you learned from the capstone project to your career or your further education, or even your next step forward after you graduate. So thank you, and congratulations once again.
Thank you.
I think, Amanda, is there anything else?
I think that's pretty much it. So yeah, thanks again to all the presenters. You all did a great job. It was very interesting to hear the different topics and technologies you use. So yeah, great job. Thanks again to everyone who attended as well. So yeah, that's pretty much it. We can go ahead and wrap up.
Thank you.